Have you heard the heartbeat of the Atlantic Ocean? You might want to hurry up as the heartbeat may be growing faint. Why would I say that? The mighty Atlantic Ocean is teetering on the edge of oblivion. The chilling reality is that planet Earth's warming could thrust the Atlantic past a point of no return within this century. Today we'll discuss the cascading consequences, the delicate balance tipping toward this potential collapse, and the urgent call to action. Now, not to get worried, but the fate of the Atlantic, and perhaps our very planet, hangs in the balance. Welcome to That's Life, I swear. This podcast is about life's happenings in this world that conjure up such words as intriguing, frightening, life-changing, inspiring, and more. I'm Rick Barron, your host. Now and then I find interesting information, a story or an intriguing fact while researching my next topic. While it might not be a big story per se, it comes down to what I call it's the little things that matter. From time to time, I'll share these segments with you and hope you'll learn something of value from the episode, even if it's a small little thing. That said, here's the rest of this story. A recent analyst suggests that the intricate ocean currents responsible for regulating climate across a significant portion of the planet might be on the brink of collapse sooner than anticipated. Approximately 13,000 years ago, there was a notable deceleration in this formidable network of ocean currents, resulting in a prolonged severe cold across Europe for over 1,000 years. Although this event occurred when human presence was minimal, contemporary concerns arise from the possibility of a similar slowdown induced by human-induced warming. Scientists are investigating the potential timing and implications of another significant weakening of these currents, which could profoundly influence weather patterns across vast regions. Researchers in Denmark have proposed that a dramatic decline in the currents, or even a complete stoppage, could materialize by the end of this century. Even the researchers themselves were taken aback by the revelation that their analysis points towards an imminent collapse, according to Susan Davidsen, a data collection professor at the University of Copenhagen. While climate scientists generally occur on the likelihood of a decline in Atlantic circulation within this century, there remains divergence regarding the possibility of a complete halt before the year 2100. Suzanne emphasized the surprise of their ability to ascertain the timing of a potential collapse. Despite ongoing scientific inquiry and discourse on the matter, she asserted that the latest findings should dispel any notion of a shutdown as a distant, abstract concern. In short, it's happening now, she emphasized. Nature Communications published a new research on how ongoing human emissions of heat-trapped gases may trigger climate tipping points, swift and difficult to reverse environmental transformations. The sudden melting of Arctic permafrost, the depletion of the Amazon rainforest, and the potential collapse of ice sheets in Greenland and West Antarctica loom as ominous prospects if global temperatures exceed critical thresholds. However, pinpointing these thresholds remain a highly uncertain endeavor. In the Atlantic, researchers delve into the complexities of ocean currents under the handle Atlantic Meridional Overturning Circulation. There's a mouthful. We'll go by its acronym, AMOC. Now, what's telling here is the intricate system transports warm tropical waters via the Gulf Stream, coursing past the southeastern United States before veering towards northern Europe. As these waters release their warmth to the northern air, they cool and grow denser, prompting their descent into the deep ocean and subsequent return towards the equator. This cyclical overturning effect facilitates a transfer of substantial heat across the globe, rendering these currents immensely influential in shaping the climate of the Atlantic region and beyond. As humanity continues to warm the atmosphere, melting the Greenland ice sheets introduces significant quantities of fresh water into the North Atlantic, potentially disturbing the delicate equilibrium of heat and salinity crucial for sustaining the overturning process. A distinct cooling trend has emerged in the region south of Greenland in recent years, manifesting as a notable cold blob, which some scientists interpret as an indicator of a potential slowdown within the system. Are you starting to get the picture? So what's the big question here? What are we facing, or rather, what's coming at us? Should the circulation transition to a significantly weakened state, the repercussions on global climate would be profound, albeit still under examination by scientists to determine their full extent. For example, cooling effects could pervade much of the northern hemisphere, while coastal regions of North America and Europe might witness accelerated sea level rises. Northern Europe could brace for harsh winters, while regions such as the monsoon belts of Asia may face diminished rainfall. Dr. DeLeeftson's latest examination honed in on a straightforward metric derived from sea surface temperatures similar to measures utilized by fellow scientists to gauge the strength of the Atlantic circulation. Collaborating with her brother Peter, a climate scientist at Niels Bohr Institute, University of Copenhagen, they delved into data from 1870 to 2020, leveraging key data indicators indicative of impending shifts in the overturning process. Peter said we not only observed an uptick in these indicators, but we also discerned a trajectory consistent with an impending tipping point. Drawing upon the mathematical properties of tipping point dynamics, Susan and Peter extrapolated from these trends. Their projections suggest a potential collapse of the Atlantic circulation by mid-century, with plausible scenarios ranging from as early as 2025 to as late as 2095. More importantly, their analysis made no explicit assumptions regarding the trajectory of greenhouse gas emissions throughout the century. Rather, it operated under the premise that the mechanisms precipitating a AMOC collapse would persist at a constant rate, essentially assuming a continued ascent into atmospheric carbon dioxide concentrations akin to trends observed since the Industrial Revolution. Experts focus on the potential happenings of these tipping points, praise the fresh perspective offered by the latest analysis in forecasting potential thresholds. This acknowledgement is particularly striking given the obstacles encountered with current computer models in global climate forecasting. Nevertheless, they voice concerns regarding specific methodologies and stress the importance of refining them further to pinpoint timing with enhanced accuracy. Scientists are employing sensors deployed across the Atlantic to measure the overturning phenomenon directly. The primary objective is to gain deeper insights into the underlying drivers of these changes beneath the ocean's surface and enhance the accuracy of future projections. However, the data collection efforts of these projects commenced no later than in 2004, rendering it somewhat insufficient for drawing definitive long-term conclusions. It's very challenging to extrapolate the behavior of the ocean overturning every 30, 40, or 50 years based on a short observational record, according to Dr. Susan Lowenser, a physical oceanographer at Georgia Tech. Consequently, Lefke Caesar, a postdoctorate researcher investigating the overturning phenomenon at the University of Bremen in Germany, raised concerns regarding using older temperature records by Susan and Peter to derive their proxy. Now, according to Susan, these records dating back to the late 19th and early 20th centuries may lack the requisite reliability for nuanced statistical analysis without meticulous adjustments. Nevertheless, Caesar emphasized that the new study underscores the critical imperative of continuously gathering data on the evolving ocean currents. Discernible shifts are occurring, and they appear to deviate from the norm, she remarked. These changes likely stem from human activities. Haley Kilburn, an associate research professor at the University of Maryland Center for Environmental Research, stressed that scientists' uncertainty regarding the timing of a AMOC collapse shouldn't excuse inaction in curbing greenhouse gas emissions. Kelly Kilburn was very blunt. It's entirely plausible that we've already reached a point of no return without realizing. I genuinely fear that by the time consensus is reached within the scientific community, it'll be too late to take meaningful action. So what can we learn from this story? What's the takeaway? The Earth is changing, and it's changing in a direction where it's never been before because it's never moved so fast before. And this, of course, is because of the CO2 that's been pushed into the atmosphere in the past 100 years. Now, either we push hard on governments around the world to get damn serious, or we just hang it up and dispense with Earth Day and climate summits. Time is not only running out, it's getting buried with a non-believer rhetoric every day. Well, there you go, my friends. That's life, I swear. For further information regarding the material covered in this episode, I invite you to visit my website, which you can find on Apple Podcasts, for show notes, calling out key pieces of content mentioned and the episode transcript. As always, I thank you for the privilege of you listening and your interest. Be sure to subscribe here or wherever you get your podcasts so you don't miss an episode. See you soon.